The Great Red Spot (GRS) is a giant anticyclonic storm rotating counterclockwise in the southern hemisphere of the planet, 22 degrees south of Jupiter's equator. It's so big that it could easily engulf our entire planet. Anticyclones on this gas giant act similar to cyclones that we experience on Earth, but they have twice the wind speed. What makes the Great Red Spot so special is its size and endurance. It is estimated that this anticyclonic storm has been raging for more than 300 years. Compare this to Earth, where the longest storm ever recorded on our planet, Hurricane John, lasted for 31 days. Although the longevity of Hurricane John is monumental by Earth's standard, it's like a speck in the face of a gigantic storm like the GRS. Cyclonic storms on Earth are born when warm vapors due to the sun's heat evaporate from the sea. This vapor forms dense clouds that release heat into the air. Under the right conditions, this leads to the formation of a low-pressure area near the surface of the sea, with warm air rising to the clouds, while the cooler air is sucked by the sea to the bottom. Since the Earth spins with a higher velocity near the equator, winds traveling closer to the equator begin to curve, which causes the cyclones to spin. On Earth, as these cyclones reach a coastline, they begin to rapidly fade and then die out completely. Nevertheless, they wreak havoc on lives and property while they are active even for a few hours. Unlike typical cyclones on Earth, Jupiter's GRS is an anticyclone that forms around an area of high pressure. Given that Jupiter is a gas giant, it has no land to trammel or calm these stormy forces. On Earth, the sun's heat drives the weather and perpetuates the storm. Switch off the sun, and these weather patterns would cease to exist. However, Jupiter's storm is not at the sun's mercy, as it comes from deep inside the planet itself, the core. The core of Jupiter is estimated to be blazing hot at around 43,000 of. The heat rises up through the boiling soup of gas, forming a churning cocktail of volatile chemicals that create Jupiter's spectacular Great Red Spot, GRS. This GRS is further fueled by two powerful jet streams, which give this storm a continuous spin, and also holds it to the red spot. Are there other such distinctively stormy spots? Yes, we have seen distinctively large storms on other planets as well, but none of them have lasted for centuries. In 1989, the legendary Voyager 2 space probe flew past Neptune, which was the first time a man-made object had come so close to the icy planet. Voyager 2 took many photographs of Neptune, but what caught scientists' attention was a smooth dark blue spot at the center of the planet. Upon further study, scientists learned that this blue spot was also a gigantic storm, formed as a result of similar regions of high pressure, just like the GRS. It was consequently called the Great Dark Spot, GDS. At its peak, winds in the GDS were traveling at a speed of 1,300 miles per hour, the fastest ever recorded in our solar system. Unlike Jupiter's GRS, this storm didn't stay fixed to a specific region, but rather moved around the planet. 5 years later, in 1994, when Neptune was observed by the Hubble Space Telescope, scientists were stunned to see that this dark blue spot had completely vanished. Although the GDS was more powerful than the GRS, due to its mobile nature, it became withered by the powerful crosswinds on the planet a few years into its torrential journey. When did we discover the Great Red Spot? As Jupiter is closer to Earth, it is easier to study than other Jovian planets. In fact, our observations of this enigmatic red spot began as early as the 17th century. Astronomer Giovanni Domenico Cassini is believed to be the first one to observe the Great Red Spot in 1665, although he called it a permanent storm at the time. Since then, we've been able to observe and track various changes happening within the GRS. Is the Great Red Spot disappearing? Unfortunately, the GRS is unlikely to last forever. Going by the trends we have seen in our recent observations of Jupiter, the end may be near for this iconic storm. Some scientists posit that it may completely vanish in the next few decades. When the GRS was observed in the 19th century, it was recorded to be approximately 25,000 miles in width. At that point, it could have swallowed nearly 3 Earths in itself. Yet, by the time the legendary Voyager space probes flew past Jupiter, the recorded size of the GRS had shrunk significantly to 14,500 miles. In the 1990s, when the Hubble telescope took its measurement, it was found that the GRS was only 13,000 miles wide. Most recently, when NASA's Juno probe collected data from this gas giant, the GRS was found to be just 10,000 miles wide. Many astronomers reckon that over the next couple decades, the GRS will shrink and become somewhat circular, and could then stay that way for some time. However, if the GRS becomes too elongated, the jet streams that were stoking the storm for centuries could ironically spell the death knell for this iconic storm. These jet streams could rip the storm off, just the way crosswinds did to the dark blue methane storm, GDS, on Neptune. Even with so much advancement in our observational instruments, there is still a great deal of knowledge trapped inside these mysterious Jovian planets, just waiting to be uncovered. Although we might eventually bid adieu to this breathtaking red spot some decades from now, the observations we make of it until then will surely give us a better understanding of how nature operates and mesmerizes throughout the solar system. Thanks for watching. See you on the next one. Oh, and don't forget to subscribe.